Cool. So welcome back. We are at week 4. This is the last week that I'll be doing lectures, and then next week we're going to do mostly show and tell and things. So I'll talk about that more as we get toward the end of class. But hopefully you've learned a lot, and hopefully today you'll learn a little bit more, and you're feeling like you're set up on a path to keep making cool stuff. So before we jump into this week's lesson, I saw some people added some cool stuff to the Slack. Does anyone want to talk about what they worked on or anything?
It's a very rowdy group we have.
I know, right? Everyone's chomping at the bit to share.
I'll just, I guess, briefly say I had a blast. It's been a kind of a crazy busy month for me personally, but this past weekend, since it was a long weekend, I had some time to just kind of explore and try out a bunch of data sets, which I try to share. It's very addictive to kind of watch, try out these different sets and see what comes of it. So I've really enjoyed the process so far.
Cool, yeah, and I loved some of the plant stuff that you were making. I have to say, I think they're better than most of the ones that I did. So I think you hit upon either a good set or just like a good training round.
I think it was illustratedplants.org or something. I can even post the link. It was a good jackpot of illustrations. But thanks.
Cool. Anthony, I saw you were busy this week too.
Yeah, I did a poll of a bunch of Japanese woodblock paintings. Got a pretty good video from that, and then I started to kind of eyeball what would blend nicely with those same paintings. And so I think this one is the pure woodblock one, and then the second one I posted was blended with different architectural drawings. So if you look at that one, there's like towers that show up, almost like sci-fi towers show up in these woodblocks paintings. So that was kind of cool, not just using a pure data set, but kind of blending them. And then I also had one that was just a kind of weird grab bag, and that's the third one that you were showing earlier. That I'm not sure why the results look the way they do, but I was pleasantly surprised. So yeah, I got really just kind of interested. It is somewhat addictive where you're just like, I just want to see what happens if I run it using this data. And yeah, a couple of times it was disappointments, but every once in a while you hit gold. So yeah, a lot of fun.
Cool. Yeah, Runway has a good business model in their hands because it is sort of addictive, and you will burn through some money rather quickly to generate lots of cool things. Yeah, I'm not sure. I get a lot of data sets end up looking like this too. I think there's just like if you throw weird stuff at it, it sort of maybe like moves toward a certain direction that it generally looks like grids and things as well. Yeah, so I think there's just like, if you think about this, like these are essentially big statistical models, right? So they're essentially like, not to say averaging everything, but they're trying to find pockets of averages. So, lots of images have grids in them. Lots of images have, these other sort of like shapes and things that generally will show up, and it ends up picking up on those and sort of mimicking a lot of that behavior. Cool. Anyone else want to share what they worked on?
I'll share some stuff.
Yeah.
I felt like let's see, how can I share? I looked out and found this Instagram that was like all hibiscus, and it was like the same hibiscus. It's like the same composition every time. So I was like, and it was like 2,000 images. And I was like, this is great. And let's see, I think I took some images where like the faces were pretty crazy. And like, you can see like right here, this like there's like glasses that really stuck in there, and some of them are really spooky. And I think the only thing can you guys see this video thing happening?
Yep.
Yeah, I got some cool, like weird ones once I was like playing with like the latent walk stuff. And then I tried doing some like processing on things just to like make some cool stuff. And like making it go really fast, and like looping. And then I was also looking at this book of poetry, and I just like dropped in this poem that I felt was like, oh, this kind of fits on here, and thought that was kind of cool. And yeah, I think the only thing that got weird is that, I don't know if I can find an example, is that some of the photos have hands, and the hands got really creepy, like in the bottom left. And so I'm not sure, like, if it just I did 6,000 steps. I'm not sure if it just needs more training, or if I should just take out all the hands and then like run it again, or like run on top of it. I think that was the only part that was like a little creepy and undesirable. But otherwise got some like cool ones that were like pretty close to like real flowers.
Yeah, it's cool. And this is a good example of when you have a data set that basically like, is really well aligned, and that they can like overlay on top of each other, onion skin style, you get like pretty realistic looking stuff. So yeah, it's
yeah,
it's rare to find data sets like that, but that you found one is really helpful, and kind of shows that you can get like pretty close to realistic, even in just 6,000 steps. So
yeah. Would that be the right way to get rid of the hands? Would just be to run it again with like take them out and then run it, instead of running it again, should I just like run it based off of this one, or should I just run it again?
that's probably what I recommend. You can probably do it, if you take out the ones with hands or Photoshop the hands out, you'll be able to get, maybe in 3,000 steps, like a lot of the hands will be removed, and you'll still have this sort of good quality image already there. So yeah, I think that's generally what I would recommend doing.
Cool. All right. Awesome.
Yeah, that's one of the areas where like transfer learning, like I know I say transfer learning doesn't really matter where you start from, but in those cases, it is going to save you a little bit of time, especially because it's so close to the data set you already have.
Sweet. Thanks.
Yep. Cool. Anyone else?
I can share. I played around with the hosted model feature, which was, again, like more addiction, I think. So let me actually share my screen. So like set up this dumb little website. Oh yeah, you can see like I spent like almost $4 on this. Me with a couple of friends, but like I have this thing where it just like makes me a new dog. And I just can't stop clicking this. But like there's a lot of stuff in here that I thought was really cool. Like there's almost like a fish texture that seems to pop up a lot. This kind of goldfish like iridescent thing, kind of scaly. But then there's a lot of just like little wing structures on her back that show up. I'm not actually sure. I was looking through a lot of the original images, and I'm not really sure that there's actually a lot of, like I don't know that she's wearing a lot of stuff, but so I don't really know where that comes from, but which is kind of interesting. But she's definitely wears a lot of scarves and stuff, so there's a lot of great like scarf and hat kind of stuff that comes out of here. But yeah,
I love the addition of Clippy there as well.
Oh yeah, just like found that somewhere and added it. I was thinking of maybe like learning about text models and trying to train one up, but I didn't get that far.
Yeah, I mean, I think I mentioned this before, but with the animal textures, you do tend to get really good faces, right? Because their owners tend to photograph them in a lot of the same poses, and then the rest of the body is just sort of amorphous because it tends to be in so many different shapes that again, the model is trying to generate like how it should be by averaging a bunch of things, or just sort of like figuring out how it works together, and then it ends up in sort of those weird places. Yeah. Cool.
I can share too. I just posted some stuff in this Slack. I was also, again, kind of like behind this week, but I found a data set from a friend's event, and I just took the entire thing and didn't come through it at all and just threw it in there. So it's looking soupy and not good, but I'm going to go through and kind of like curate it a bit more because there's a lot of like images that don't fit in it. But I think that I'll be able to get better results after I spend some more time coming through the data set.
Yeah, definitely. That's definitely a thing that happens is yeah, so it is I can see sort of here that yeah, it looks like it's from like a warehouse party or something. Yeah.
Yeah, yeah, and it's cool because like it was just their 10-year anniversary of their party, and so I want to give them a little like card or something. But you can like see the room where it is, even though it totally doesn't look like it. It's just kind of a fun little experiment.
It's also funny that people look like blobby people, but they still look like people. Like you can tell what it
Yeah.
is, right? Yeah. Yeah. Cool.
I totally forgot to do this homework. I'm going to be honest. I've been camping in South Dakota, but I'll be sure to catch up next week.
Yeah, all good. No, it's you know, camping sounds nice right now, so take advantage of it when you can. Cool. All right. So lots of cool stuff. I think this week we'll also add some other cool things for people to play with. And I think also like the cool thing about hosted models is that when you learn a little bit of this stuff, you can also then attach that to a hosted model, and it'll be a pretty fun way to play with things as well. Let me go ahead and share my screen. Cool. So yeah, so this week we are going to look at interpolations and different types of interpolations and different ways to manipulate essentially a StyleGAN model. This will work mostly with vector inputs. So it'll mostly be for your custom model, but you can also use it for any StyleGAN model you find on Runway and BigGAN as well. Might need to tweak it a little bit for BigGAN, but we could get it to work for that as well if you're interested. And we'll mostly be using p5.js. So you don't need to know how to code for any of these examples that I'll show you. But if you do know how to code, you can dig in and sort of see how we're generating things inside of p5. As a reminder, next week we will be doing like a group share critique. That can be as loose as basically what we just did. Maybe show a little bit of what you've explored like throughout all 5 weeks. Talk about what interested you, talk about like what you might want to do next, that sort of thing. And then hopefully there's a little bit of feedback from the rest of the class about like, this is really cool. Wonder if you could find like a data set that does this or that sort of thing. So don't worry, it's not like a presentation, like there's no grades again. It's just like, just show what you worked on and like talk about like what you found interesting or maybe what met your expectations, what didn't, and like what you're excited about working on more. So it'll be pretty low key. Normally, like if we were not in a global pandemic and we would like have some drinks and like hang out and do it together. But so maybe everyone can like bring their own drinks or snacks or whatever and enjoy that week. It's basically just like a time for all of us to show all the work that we're working on and like celebrate like, you know, this is a new thing for everyone, I assume. So, you know, I'm glad that people are enjoying making things, and that's really the whole point of it. And just to sort of like have some time to hang out and like see more stuff. So as I mentioned today, we'll be looking at interpolations. So I've got 4 notebooks that I'll show you. So we'll go through all 4. They're not notebooks. I shouldn't even call them notebooks. I just finished wrapping up a class on notebooks, which I'll discuss next week if you're interested. But we'll just be going through some P5 web files that anyone can use. They're public, so you can go ahead and grab them and use them for your own projects or just play with. So we'll look at linear interpolations, noise loops. Those are sort of 2 of the more common sort of interpolation methods. So obviously linear interpolations you can do inside of Runway today, but we'll look at maybe some things that you can do with the P5 notebook, and especially in terms of like generating new images or that sort of thing. You'll get higher quality PNGs out of this. So we'll look at how to do that as well. And then we'll look at 2 sort of, I don't want to say advanced, but just like different ways of playing with StyleGAN and the vector outputs or vector inputs. We'll use sound. So as a way to, we'll put an audio file in P5. We'll record the amplitude or loudness of the audio file, and then we'll use that to interpolate some images. And then we'll look at a text example. So this won't be like attention GAN. It's like a hacky version of attention GAN, but I'll walk us through how we use that. And I actually had a student previously take a model like this and turn it into like a website, which was pretty cool. All right, so interpolation. So I know we talked about this previously before, but just as a reminder, StyleGAN has this concept of a dimensional space. It's called latent space. StyleGAN uses 512 dimensions. So you can think of it like 3D, except 512. If you are interested in looking at like BigGAN uses 128 dimensions. Basically, these models can use any number of dimensions you want. The people who create them sort of like have reasons for why they create certain sizes. But yeah, BigGAN's 128 dimensions. So if you do want to take some of these notebooks, you'll just need to sort of tweak it so it only produces 128 dimensions. Yeah, so imagine that you have a space like this. And yeah, so Runway uses a thing called, I don't actually know if they use PCA, but they basically use a mathematical algorithm to sort of flatten it into 2 dimensions. So it's sort of a grid of images to like show how different areas of the space look. And the way you basically make an interpolation, right, is that at one point in space, you have a certain point or a certain image. At another point in space, you have another image. And if almost like a cell animation, you interpolate or from that point in a certain number of frames, it generates an animation. So we're going from here and we're just slowly interpolating over here, and that generates an image. So we looked at this just briefly inside of how it can work inside Runway, but we can also use p5.js, which is a JavaScript editor. It's built on sort of the concepts of processing. We can utilize that to actually generate our seeds or to like generate our interpolations as well. And I think what's sort of helpful to understand here is that let's say, you know, again, this is a fictional space, but let's say we have points in space and some of them are closer to each other and some of them are further away. The points that are closest to each other, which is hard for us to like figure out, but if you have the same number of frames between each of these points, the places that are closer to each other are going to feel like they're moving slower, right? Because you're moving a much a shorter distance over the same period of time, versus an area where you've got images in far off distances. This is going to feel like a fast movement. So one thing you're going to notice is with linear interpolation, it doesn't feel really smooth because you can't really have a concept of exact distances. Some people have written some very complicated algorithms in order to like smooth out the distance to make it feel as even as possible. But in this case, you'll get a little bit of this sort of like, it feels like it's slowing down and then speeding up. And that's sort of one of the downsides of linear interpolation. The upside is that we know exactly what these middle points are, right? We're picking those points and we're able to say, go from this point to this point to this point. So if anything, we at least know those interpolation points are going to look good. So we're going to use P5 to do this. P5 has a web editor. I believe it's just editor.p5js.org. And basically the process that this is going to work from is you're going to open up your P5 file, and it's just a code editor that lives on the web, and it comes with a couple other files, and I'll walk you through that in a minute. You're going to start your model in Runway. So your model has to be running inside Runway in order for you to talk to it from P5. And for those of you that know a little bit, this is just going to work over our network protocol. So we're just going to do like localhost 8000. It's going to talk over that. You'll be able to talk to Runway and say, P5 will generate our 512 dimensional vector. It'll just be an array. We'll send that array to Runway, and Runway will take that vector and then return a image. So basically, we're going to use P5 as basically a way to talk to Runway and say, I want this exact image at this exact point, and then I want to animate between these, and we'll do the interpolation inside of P5. So it's true that like Runway is a little bit easier, and Runway has now, I believe, built up some functionality that makes it a little bit easier to use. I do think there's some nice stuff about this, which is P5, when you turn on download images, and we'll look at that in a minute, you'll download PNGs. So hopefully they're a little bit higher quality than the JPEGs you probably get out of Runway. The downside is that you have to do a little bit more manual work to get all this set up. So just be aware that like sort of trade-offs in both these scenarios. We'll look at some other examples that you definitely cannot do inside of Runway. And I think that'll sort of highlight some of the better points of it as well. So basically what we're going to do is in P5, we're going to download every single frame of an interpolation. So we'll get 100, 150 single framed images. And then we're going to use a tool called Ffmpeg to actually combine them all into a video. And I just realized I didn't link the video to installing Ffmpeg in here, but if you don't want to use Ffmpeg, which is like a little bit of command line wizardry, you can also bring them into After Effects or bring it into Adobe Premiere, and you just bring them in as an image sequence. We'll look at this. They'll basically be, they're named in like 0, 1, 2, 3, 4, 5, all the way up to whatever number of frames we have. You could drop those into After Effects and use an image sequence to generate that as well. So this class will be a little bit more coding heavy, but hopefully you can just follow along and use these commands if you're not into coding. But there are other ways around it too if you like are not a person who wants to use the command line at all, which I totally get. It's taken me a couple of years to get into it myself, but I'll show you sort of the easy way, and then I'll show you the harder way using command line. And then this is the Ffmpeg command. So basically anytime, I never remember what it is either. So I'm often looking this up or, running the same command, or I have it saved to a notebook somewhere. So you don't need to know exactly like what all this means. I'll walk you through it, but you can always just copy and paste this command and have it work. All right, so let's look at linear interpolation. So all of these files are linked to from the slides, and the slides are already up on the class site, but I'll remind you all when the video goes live as well, so you can grab them from here. So this is the link to our linear interpolation notebook. You'll see it just says runway interpolation. So let's go to runway now. So we have to have both open at the same time. I'm gonna grab one of my models. Let's grab this one. Now there's a couple of things I need to do for linear interpolation. Just like you use in Runway, the first thing is you need to define a couple points. So what I'm gonna do is I'm gonna run my model here. And once it's running, I'm gonna grab, for this demo, I'm just gonna grab 3 points, but know that you could generate any number of points. You could grab 12, 20, 100. 100 might like be really annoying to look at inside of P5, but you can still do it. So we're gonna generate some vector inputs here. Once it's up and running. So I'm gonna change my truncation value a little bit. I'm gonna make it a little bit smaller. I'm gonna regenerate my grid just so I have a bunch of different samples. So again, the way to get, basically what we want is we want just the vector, which is a 512 dimensional array. So the way to do this is, I believe I talked about this previously, but in case you've forgotten, you can click on an image, and instead of going down here, which is save image, you go over here, which is save vector. So I'm just gonna go ahead and click the save vector button, and I'm gonna hit save, and it's gonna save to my desktop, and I'm gonna say find, replace. And then you can click this very quickly, or you can go back to your desktop and open this. So if I open this in a code editor, you should have a code editor. I just recommend like Sublime Text or something, or Visual Studio Code. They're all free. Do whatever you want to do. You'll just need to be able to open a file in a text editor, and all you're going to have is this is a 512 dimensional vector. So I'm going to do this 2 more times with a couple more points. So let's go back to Runway, and I'm going to select. Let's see if I can zoom out a little bit here. Let's grab this pink one. So I'm gonna hit save vector. And I'm just gonna name this vector 2. And let's grab this one. And we'll call this vector 3. So now I have 3 vector points, and all I wanna do is animate between each of them. So what I'm going to do is I'm going to open up all 3 of these inside of my code editor. And let's grab them one by one. So we're going to start with number 1. And we're going to go to the P5 file. So see here, all you really need to worry about is if you're not a coding person, is just worrying about these variables. And for most of you, you won't really need to touch that many of them. So the first thing I'm going to do is I'm going to come in here and see where it says let vectors. This is an array of vector arrays. This is the most annoying part of this code file, because unfortunately you can't just read in those JSON files into P5. I'm just going to empty that out. So basically what I should have is I should have a file that just says let vectors equals and then a open square bracket and a closed square bracket. So I'm gonna hit an enter here, and I'm just gonna paste in that first vector. So it's just a bunch of numbers. And then I wanna do is I wanna come down to the very end of that line, which is a bracket, and I wanna hit comma, and then I hit enter. And then I'm gonna come back over and I'm gonna grab vector 2, copy, paste, and then comma, and then take vector 3, copy, and paste. So this is now basically I've got these 3 vectors held inside of P5. And now what I can do is I can actually run some code to interpolate between those values. And the interpolation code, if you're interested, is actually just here. This is a very it's not even that fancy, but it's basically just saying between this point, do this thing. Or here's the first vector, here's the second vector, here's how far along between those I am. And then you just run this script or this little algorithm, which will basically give you the point between all those with the 512 vectors. And actually, I think this one might only work with 2. Let me see here. Oh no, this will work. Okay, this will work fine. So I've got 3 vectors in here. I've got my truncation value. Let me make sure my truncation value here matches what I was using in Runway. And it is 0.7, so it does. So one thing to know is that if you have a different truncation value here than you do inside of P5, you will get slightly different images, right? So if it's 0.6, it's going to be ever so slightly different. But if it's 1.0, it's going to probably be very different than the 0.7. So make sure that matches. Next thing I want to do here is how many frames how many frames between each point do I want? This matters a lot depending on what you used for your frame rate. So frames per second times, or this divided by frames per second equals how many seconds of a transition between your frames are. So most of the time I'm going to use a 24 frame per second video rate. You can make it 60 frames per second, and then this would be 1 second. At 24, I think this ends up being what is it? It's 2.5 seconds or something. Yeah, 2.5. So actually for this demo, I'm gonna make this a little bit shorter just because it does take a little bit of time to generate these images. So make 2 seconds between each one of these vector points. So it'll be either a 4-second or a 6-second video, depending on if I loop it. So lastly, there's also a thing in here called loop. If I set loop to true, that is going to go back to the very first vector. So there's 2 ways you can make it loop. You could either grab the first vector and put it as the very last vector and set this to false, or it's easier just to say, here are 3 vectors and make sure it loops back to the first one from here. So if you want to do that, you can add the loop. And then lastly, we're going to turn on download images. So you used to be able to render a video directly into Runway, and they've kind of removed that feature in order to have you use their tools. So now the way to download these images is actually to set this to true. And all it's going to do is it's going to download them all to your downloads folder. So we'll look at this in just a minute. Second, if you did train if you trained a smaller data set like 512 or 256, make sure you change this number. Otherwise, you'll end up with extra space in your images. I think most of us probably did 1024 by 1024, so it's fine to leave this as is. Okay, so I've now set up all my variables. If you're interested, the code is all below here, but this is just all the stuff I've set up for variables. So if you're not interested in reading code, this is all you need to do, set these 8 variables. Now, one thing we need to do before we hit play here is we want to make sure that we're actually running inside of Runway. A lot of times Runway, as you set everything up, will turn off. So make sure this is running. So we're gonna hit run remotely. I feel like sometimes this fires up in a second, and then other times it takes a whole minute. And of course, every time I try and do a live demo, it'll be the whole minute. One thing to note is that if you know what network protocols are and you are running a lot of them, you might want to double check your network over here just to make sure that you're on the right port. So this is Runway defaults to port 8000, which is then set here in P5. Is set here. So if you know you're running other things over ports, make sure that these match up. Come on. There we go. Okay. So now that I know this is running, I'm going to come over here and inside of, actually I want to do one thing before I do this. I was playing with this a lot yesterday and I want to make sure that all of these are deleted correctly. Cool, yeah, they are. So these are just going to download to my download folder, which is very, very messy. So I just want to make sure that it was semi-clean. So now I can go ahead and hit play here. And what's going to happen is it's going to slowly download all these images. You're going to see them sort of generate inside the preview window. So we're going to go ahead and press preview. And you'll see here that that's saying it's sharing image 1, 2, 3, 4 of how many total images we're doing. We're doing a total of 144, which I believe is like 48 times 3. And you can also go to Runway, and you'll see that it is also being pulled in here. So it's switched over to the HTTP tab, and you'll see that the Z is getting passed in here, and you'll see that we're sort of generating these images. Now, this can't really run at real time, right? So it's taking 330 milliseconds per image. If you were using a 256 by 256, you might be able to get real time, but still over network and other things, it's a little tricky. So this isn't real time. It's pretty hard with a lot of this stuff to get real time inference on this, but you're getting it pretty quickly. And it's also worth noting that because I'm running this model, I am being charged. So this model is running at 5 cents a minute or whatever. So if you set one of these to generate like a 3-minute long video, it's going to take a while. I have also found that sometimes I probably wouldn't go any higher than a minute using P5 because I do find that it times out sometimes. So if you're going to do more than a minute, you might sequence just because it can get a little tricky and get a little messy sometimes. So just be aware of that. And you'll see here that I am downloading all of these to my Finder. This takes over my computer. Should probably quit some of these applications. So all these are being downloaded. And what we're going to do is when this is finished, we're going to move them all into a single folder. If you're on a Mac, there's a simple command. You just select all the files and say new folder with files, and it'll generate them. If you're on a Windows, you probably know the command. I haven't used Windows in years, but there's probably a way to do it. So we're almost finished here. So, this isn't the slowest thing on earth, but for what's going to end up being like a 6-second video, it is a little slow. But what's nice here is I am getting PNGs. So these are as high resolution as you can possibly get out of Runway. So a lot of times, there is still a lot of artifacts, and that's just because of the StyleGAN model. But if you are interested in just getting PNGs, this will give you a really nice high quality image, or the highest quality you can get out of it. We're almost finished here. Cool, so we're done. So we finished generating the image 144 of 144. I recommend hitting stop here. That's just going to make sure that the process ends on the P5 side. And then you can also come over here and hit stop on your Runway model. Okay, so now I have all these frames. So I'm just going to come in here and I'm just going to grab all of them. And again, on a Mac, I'm going to hit Control click and then hit New Folder with Selection. And let's just name this folder LERP. So now I have all of these images in here. So there's a couple of things I could do. One is I could just take them. Let me see if I have After Effects open. So let me open After Effects. I'm more of an After Effects person than a Premiere person, but if you're interested in using, I think they can import image sequences no matter what. Probably also like Final Cut and other video programs as well. So the simple way, if you're not interested in getting into the command line stuff, is just to import this as an image sequence and then export it using like a render. Cool, so I can just double click in here. And if I go to my downloads and I grab the LERP folder, you can just click on Create Composition. Actually, I guess you have to click inside the folder. Yeah, and then if you just select all, I believe, you can use PNG sequence, and then if, I don't, it's not even gonna let you do that. Okay, so if you just hit PNG sequence, it's gonna convert it into a PNG image sequence. And here you go, here's a video from this. So now I can just actually go to composition, add to render queue, and then you can come here and you can set whatever lossless compression or whatever you want. So this is probably the easiest way if you're like not comfortable using the command line. But I can show you a really simple way to actually generate this. So let's just go ahead and let's add this, say in here, I want to go to downloads. We'll just call this AE Lerp. Go save, and we'll go to render. This should render pretty quickly because it's just a bunch of image sequences. It's probably using Ffmpeg behind the scenes, to be honest. Cool. So here is our video. And so there's our interpretation, our linear interpolation. So let me show you the slightly harder version. This ends up being the version that I always end up using anyway because it's sort of memorization. It doesn't require me opening After Effects. The first thing you want to do is open up a terminal window. So I'm going to create a new window here. And I'll make this a little bit bigger for everybody so you can see. So I don't want to turn this into a terminal class, but if you are interested, I can share some videos on how to use the terminal. But really quickly, the most basic way to do this is click on your folder name and just do Command C. That just copies the path. And then we're going to do CD, which is change directory. And we're going to paste that in. And so now I'm inside of that folder. If I do LS, I see all of these images. So now we're going to run this really simple Ffmpeg command. Man, really making my computer crawl today. There we go. So let's go back. And so I'm just going to grab this command. And you don't really need to know what any of this means, but I'll paste it in here and just talk you through it. So this is using a tool called Ffmpeg, which is like a very, very popular video conversion tool. The installation is fairly straightforward if you've ever installed any software using the command line. What this is going to do is it's going to take all of our images. So it's going to take every image and it's going to look at them in the order. So this present 04D says look for every integer digit that is 4 numbers in a row. So it's going to start at 0000 and it's going to go 0001. It's going to basically like generate an image sequence for us. This R is equal to what is the frame rate? So I've set it to 24. If you want to set it to 60, you could set it to 60. If you want to set it to 30, you can set it to 30, 10, whatever. This is a frame rate. If you're not familiar, on the Mac at least, you can do option click and that'll put your cursor wherever you click. Terminal is a little weird in that like normal commands don't work or like normal text editing commands don't work, but if you do option click, you can edit this. So we get to make it say 30. I'm gonna leave it at 24. This is all codec stuff. I actually honestly don't really know what all this means. I just know that this is a decent compression algorithm. If you want to look up and get higher quality compression, you can probably look this up, or lower compression or whatever. And then the last thing that we want to do is we want to give it a file name. So this will be, video output. So I'm just going to say ffmpeg-lerp. So, there shouldn't really be any difference between these videos, but just sort of to look at them. And then you're going to hit return. And all this is going to do is just going to like basically do what After Effects did, which is just stick all these things in an image sequence. And so now here I have ffmpeg-lerp. And it should pretty much be the same video. It feels like it might be a little bit slower. This one might have defaulted to 30 frames per second. One thing you will note is that I was doing almost lossless compression in After Effects, which means my video file was really big compared to Ffmpeg, which has a slightly higher compression and it was only 3 megabytes. So again, do whichever you're most comfortable with, but I tend to default to Ffmpeg now just because I know the commands and I sort of know the process. That is basically the process of doing linear interpolation. We'll look at a couple other examples in P5, but are there any questions just about sort of the overall process of this?
I guess my question is like, what's the difference between this and like the latent walk, like generator and Runway?
Yeah, the truth is Runway didn't have their latent walk generator up until like a month ago. So there really isn't a big difference between this. So if you just want to do a latent walk, I definitely would probably recommend using Runways. One reason you might want to use this is you want to have better control over the compression you use. I'm not sure about what compression the latent walk uses inside Runway. I feel like it's a little bit, chunkier. So if you're a control freak and you really want to like have high res PNGs to create that videos from, this is the process to do it. But I would say in general, if you just want to do a quick lerp, just do it inside of Runway. You also have better like adjustments where you can say like between these 2 frames, I want this to be longer, or between these 2 frames, I want this to be shorter and I want easing. So Runway definitely makes it cleaner. The next 3 demos we'll look at will make it like, we'll show you things you can't do inside Runway.
Okay, cool.
Yep. Cool. Let's actually jump right into the next demo. So this was learning interpolation. Remember the idea here is that you set points and that you're able to animate between those points. So the key here is like, you can say like, hey, I want this point, this point, this point, this point, and I want you to animate between all of them. The next thing we're going to look at is what I call a noise loop. And this essentially does something a little different in the sense that it starts at one point and it generates sort of this like long looping pattern. And it does it in sort of what I would describe as a noisy way. So it doesn't like just create a clean circle. It sort of meanders through different spaces, but it always ends up back where it is. So this is probably more likely what, when you make that demo video or when you finish training and Runway produces that demo video might be a noise loop. I'm not actually sure. But basically this is a process where like you can do far less work here and generate like a video. So basically remember that you're not defining any of these points, to be honest. You're just saying generate a video that loops for me. So this is kind of a fun way to just generate a bunch of different like looping videos. And we'll sort of look at a couple like ways in which you can tweak things. So remember, this does start in a random place, and it uses a thing called simplex noise, if you're familiar with that, but it always ends up back where it is. So this will always loop, which is very nice for stuff like, looping GIFs or Instagram or whatever. This will also generally feel more fluid. So again, remember how like because of those points and where they are in space, it'll sometimes feel like it moves fast and then slow. It'll kind of feel like herky-jerky. This will generally, it won't always feel perfect, but it will generally feel more fluid. So there's, just a way to sort of generate a little bit more of a fluid feel in your animations. This has much more limited controls though. So whereas the other one you were saying, I want to go from this point to this point, and I want to see these 2 frames, this sort of has a rough concept of diameter, which is really like more of a metaphor. It's like, how wide of a space do you want this to go around? And then how many frames do you want to generate? So the idea is that diameter is sort of like, imagine that you are starting here from a center point and you're generating a loop. If you make your diameter really small, you're going to go over a small area. If you make your diameter really big, you're going to go over a very large area. So a bigger diameter will give you more diversity. But if you set the frames at the exact, like let's say I want to produce 100 frames at each of these, if I set a small diameter and a small number of frames, it's going to feel it's going to feel like slow. If I set a large diameter with the same number of frames, it's going to feel really fast, right? Again, because it's traveling a further distance between frames. But you could set a larger diameter with a larger frame rate and it would still feel slow. So like, you have a little bit of more control here, but you have to remember how diameter and number of frames work. And you might actually have to just generate a couple different videos to sort of see what feels right for you and what you want to do. But I do like this as an example. I will often use this from the first time I make a model because I can sort of see, if I set the diameter pretty wide, I can see a wide range of the space that I generated. So it's kind of a nice way to get like, it's sort of like a travel around the world and sort of see what happens in your latent space sort of thing. let's take a look at how this one works in P5. I'm going to go ahead and close our linear interpolation file. So this one, our variables here at the top, you will see we are never setting anything like a vector. So we don't give it any vector. It chooses a random vector. If you want to sort of start kind of in the same place, you can use this random seed. This random seed is meant to kind of have a generator, but the truth is, unless you set all of your values to the exact same, the random seed won't actually reproduce the same video. So just be aware that like this is pretty random. You don't have a whole lot of control over it. There is a truncation value here. There's frame count. So again, here what I've done for the frame count is I've actually decided like, let me actually say how long my frames per second is and how many seconds I want to generate video for. You know, you can do this if, again, if you're going to use 60, you would just say 60 and then I want it to be, you know, 10 seconds long. This is just easy math for me to remember, like, what am I doing and how many am I producing? I'm going to, again, keep this pretty small so our demo happens quickly, but I would definitely recommend that you generate this, like, you play with these values a lot. Diameter 1 is like not that big. Again, this is sort of a metaphor. I recommend just playing with it and sort of seeing what happens. And then we are going to download our images here. So what I'm going to do is I'm going to record one video. I'm going to do a diameter of 1, and I'll do another video at a diameter of 5, and we can sort of see how different they are. But I'll keep the random seed. Let's just set the random seed to 10. So I'll keep that there. So once again, we need to make sure that we have runway running. And it better not take 3 minutes again for me to start this up, but let's see. There we go. Cool, so now we're already connected, so we can go ahead and run this command from here. So this is going to produce, what is it, 24 times 3? It's going to produce 72 frames. It's going to be really, really fast. So what I might actually end up doing when I render it to video is I might render it at a slower frame rate, but let's just run this and see how it goes. And if I go back to runway, it's kind of easy. You can watch sort of the animation happen a little bit easier over here. Cool. That looks like that's done. So we'll go over here and we will hit stop. And really quickly, what I'm going to do is I'm just going to move this into a new folder. And then in order to be a little bit more efficient here, what I'll do is I'll restart the command with a new diameter value so you can look at the difference. So let's just move this in here. So let's call this noise and then D1. So D, just, I tend to name these like sort of what I remember, like just so I can go back and be like, yeah, I like the diameter of this or like whatever. So I'll also often do like how many frames per second. So it's, I think it was 72 frames total. Just this helps me sort of remember and I can come back to stuff and reproduce similar ideas. So while I generate the video for this, I'm actually going to run this command again, but this time I'm going to change the diameter to 5 so we can look at the difference. So I'm going to run this, and then behind the scenes, we'll set up our Ffmpeg. So I'm just going to go ahead and copy this folder path and come back to terminal. And we're going to do CD and then paste in the path. And then a nice little trick of what you can do inside a terminal is you can press up to get your previous command. So I'm going to press up, and then that gives me this command again. I'm going to change the frame rate to 12 just so it's a little bit slower so we can actually see it. And then I think everything else here is good. Maybe I'll change the name a little bit. Let's see, let me do that. Yeah, so let's do Ffmpeg, and then we'll call it -noise -D1. We'll hit return. That'll generate our video. This shouldn't take too long. Cool. And that finished. So let's take a look at that video. And just on time, like I meant it to happen that way, we'll folder up these set of images. We'll call this one noise -d5-72f. And then let's go ahead and, so I'm just going to quickly stop P5 and stop runway. And let's go ahead and turn this into a video. So we'll copy this path and we'll paste this in. CD. Press up twice. And then at the very end here, we can do, this is noise D5. Cool. So now I have both those videos. So let's go ahead and just open them up side by side. So we're going to open up this one, and then we're going to go in here. And let's open up this one. And I can't really play them at the exact same time side by side, but I'm going to do the best I can. So you also see that they started in different places, and that's because of the diameter being different. So again, even though you have the same random seed value, they don't start in the same place. So let's go ahead. I'm going to really quickly hit play and then play. So you'll see the one on the right, which was much wider, did a much more diverse path. And because they were the same frame rate or the same amount of frames, this one felt far, far faster. Whereas this one felt pretty, this one feels pretty fluid, and that still like loops. And I would say it feels fluid in that there doesn't feel like a lot of herky-jerky motion. This just almost feels like you're seeing a bunch of different frames. You're seeing a little bit of animation. So if you're going to make a wide diameter animation, you probably want to add more frames so you can actually see it animate. So that covers noise loops. Any questions? Okay. Cool. So why don't we take a break? Let's take a break till 5 after, and I'll get set up for our other demos, which are going to be about sound and using text. Cool. All right. So see everyone in like 7 minutes. Did anyone come with any questions about this process while they were in the bathroom, getting a drink, whatever?
I didn't have a question. It's not really about the process, but one thing I was wondering is, like, I think you mentioned about how models tend to like really organic shapes. And I was wondering how, like, if you were to run a bunch of like vector shapes, like, would it end up looking really shitty or?
Yeah, it'll generally end up looking really shitty.
Okay.
We didn't really cover that in this class, but I have some videos explaining a little bit about how convolutions work. And convolutions are generally like, that's basically the process you'll see here. And convolutions are really generated to like find photographs or find animals or find more organic shapes. So it does really struggle with stuff like geometry. StyleGAN technically should be better, but it still really isn't. I think especially because it's trying to find basically what I've read and understood at is like, because StyleGAN tries to force you into a space that is interpretable, meaning any point in that space is a realistic new image. So it basically forces you into this space where things can interpolate and morph. That tends to force it into less geometric shapes as well, right? Because you think about it, translating a square to a rectangle or a square to a triangle, somewhere has hard edges, that morph has to be somewhat amorphous or non non-straight edges as well. So there's a chance that if there are probably some other models out there that don't force you into these interpretable latent spaces, that might get you better shapes, but then you can't interpolate between them. So it's like sort of a give and take between a lot of these things. But yeah, definitely it struggles to find like really rational, like straight line geometry for sure.
Gotcha.
Cool. So let me jump in and let's talk about a couple other examples of ways we can interact with these vectors. So one thing that's really important to remember is that this is it's just a numeric value, right? So a z vector is 512 numbers that are a float number between -1 and 1, right? So -0.25, negative, or positive 0.375, whatever. So anything that you can generate, like if you can generate a number value using any other source, say like a CSV file or an audio file, or what we'll be playing with in just next is text. If you can generate a number from that, that can then be mapped to that -1 to 1 value. And that sort of is like the key to pretty much any of this work past what we basically have done, right? So basically we want to generate a value and want that value to stand in a place for a vector. And then we want to take that vector and we want to change that number and have the vector change with it. So the next two demos that we're going to look at are basically what sort of data can we take as input, and then how can we manage that to be an output. Another reason, or another thing to think about is like, because this isn't real time, trying to do like real time mapping is kind of a trick. It's really tricky. So when we look at the sound version, we'll actually have to record the sound first, then take that and manipulate it into the vector later. So if you're trying to do something like, a common P5 demo would be like, take the mouse position and take the XY coordinate, and then as you move your mouse, it changes. With this, it's gonna be really hard because we don't have that one-to-one latency. So you might think about ways in which you can do some smoothing or other things to make that happen. So just be aware that's kind of a limitation of this. I do expect that probably in the next year or two, we'll have real-time StyleGAN models. We just don't have them yet because of GPU limitations, technology limitations, some other things. So I've started to see that people are able to generate StyleGAN models that are real-time, but they're doing some pretty heavy processing before it actually becomes a model. So that's just one trick to note. So because we don't have real-time, we kind of are limited in terms of what we can control. So what I'm going to show you is just a really simple text generator. So let me go ahead. Oh, I didn't really want to do that. I want to just click on this link. So let me just show you what this does, and then we'll talk about how it works behind the scenes. So first thing is I'm going to set up my runway, and I should have, of course, hit run remotely before we started talking. So once this is set up, I'll show you how this works. All right, that was a little bit faster this time. So now we've got our model running. We can go ahead and hit play over here. And so you'll see this is not the most beautiful UI, but we have a text window here. So I'm just going to go ahead and type in some words. So let's type in artificial. And I get an image out of this. Now, again, I could probably make this a little bit cleaner and actually like design my UI a little bit better so everything fits in the right space. But basically, we've got this way to type in words and the words generate an image. And if I go back and type in artificial again and spell it correctly, I should get the exact same image. So what are we doing here? This is not like attention GAN where we're doing some sort of like, if I type in the word, dog, I don't see a dog, right? It's like, I just see a representation of this. So all we're doing is we're taking these letters and we're breaking each of them into a character, and then we're converting that character into a numeric value. And in this case, I think we're just using like an ASCII. Yeah, we're using like an ASCII character code. So if you don't know what that means, don't worry about it. But basically all we're doing is we're saying like, hey, let's turn this value. So I just like switch that to dog. Also dog with a capital D will be different than dog with a lowercase d. Because those are different values to the computer. So what we're doing is we're taking this, we're adding up all those letters into a numeric value. That numeric value gets passed in as a random seed. And random seeds are basically like a placeholder for a random value. So this is semi-randomness, it's not really random, right? It's saying like, anytime you see this number as the random seed, use this random value. So we're using this random seed to then generate our 512 dimensional vector. So we're actually just down here, we have a create Z. So we're literally just taking that random Z value and then creating 512 values between -1 and 1. So this is like hacky, but this is a cool interface. So one of my students recently like basically turned this into a website where you just type in any word and you would get an image back, right? So this is, again, this is like the fun of things. And you could obviously imagine like, okay, how do I take this further? Well, what other inputs could I have, right? So you could almost take something like, you could turn on like a webcam and have the webcam read pixel values and then map those pixel values to -1 to 1, or map those pixel values to something like, you know, a random seed value and then generate a random seed. So this is just a demo of like anything you can generate that generates a number, you can turn that number into a random seed value that then creates a Z vector. Or you could have it generate like the exact Z values, right? So another thing you could do is you could take audio in and you could have it read the volume at every point in a song and have like one song generate one image, right? So again, this is all just mathematic manipulation. So if you have a 512 dimensional vector, you could have it generate all 512 dimensions at once, or you could like take a value and apply that to the individual vector element. So again, remember that's between -1 and 1. So as long as you're generating a value that is that, you will have this work in any way, in any sequence. So this is like a very straightforward demo, but I think if you do know a little bit of code, like you can sort of take this and run with it. So this is just where we're doing the random seed value. This is where we're creating our Z value from that random seed. And then this get image from runway is just passing basically that Z value into this callback. So just calling this URL, and then it's passing in this data. Any questions about that one?
One quick question, I guess. I think I've seen examples recently, and I'm guessing they're using P5, where people are taking audio and making it a bit more reactive to the animation. So maybe when the bass drum hit, it kind of like accentuates on certain frames. Is that using sort of a similar process, but just extrapolating on it and building it out? Okay.
Yeah, so we'll look at the next example will be sound, and we'll look at a little bit of how to do that. This will just use volume. So yes, basically, if you want to do something like just the bass, you'll either need to do like a source separation, which is there are machine learning models that'll separate out all the sounds of a single track, or you can use like a filter pass. So like if you can do like a low pass filter to just get the bass track, and then you can just key the sequence to that.
Cool, gotcha.
But yeah, so we'll look at a really simple example of that. The examples you're probably talking about, which I can, if you have some, I would love just post them in the Slack channel because I think people would like to see them. There are different things you can do. So one thing I noticed, or one thing I talked about here is like, you can have this create a Z value, right? You could also have this change the truncation. So, you know, you could add these up and then somehow map it between 0 and 1, and that 0 and 1 would be your truncation value. So truncation values, if you manipulate those, one thing I'll note is that tends to be really, really slow. If you change the truncation value and send it to runway, it'll take like a second to get an image back. So it's a lot slower, so just be aware of that. But you can play with like actually manipulating the truncation value. In some cases with StyleGAN, this is the thing you can't really do in runway, but some people have also mapped what we call feature vectors. So in the case of something like a face, they've mapped a way to actually figure out what vector opens people's mouths. So they've actually then been able to take like a vocal track and actually like lip sync essentially with that. So this is stuff that is sort of like definitely advanced level and you can't really do inside a runway, but that's sort of getting at what we're doing here, right? So it's like anything that we can do to bring in a mathematic value, we can either manipulate the whole vector, parts of the vector, or like other values that are going to change how the image is manipulated. And that's essentially like all the process for any sound reactive stuff, especially using these models, is that.
Cool, thanks.
Cool, so why don't we actually jump in and take a look at this example. So interpolation using sound. So there are better ways to do this, to be honest. The fact is that P5 wants audio to run real time, but we can't run real time image generation. I've kind of built this up to be a hacky way to generate audio. There are probably other tools like processing or Python or other things that might be a little bit better and a little bit cleaner to do this, but I've got this set up so that it'll run no matter what you do. So the first thing we need to do within this model is we need to upload a song. I've got a song already uploaded here. Oh, also one thing I should mention is that when you open these files, you won't be able to save them yourself. What you'll need to do is you'll need to go to File and then Duplicate, and you'll need to make a P5 account. So if you want to save out any changes you make sure you create an account before you go ahead and do all this work, because there's also like, this is like open source code. It's like by a bunch of volunteers. It is not the cleanest like saving solution. So I'd recommend making a P5 account, opening the file, duplicating it very first thing you do into your file system, and then making any changes you want. You will very likely lose changes. This is like, just warning you, it's like a little crusty. It's not the cleanest editor. You can, if you want to look into how to use P5 using like a normal like code editor, you can do that as well. I just like this method for folks who are not like super like code efficient or code savvy. But yeah, so first thing you need to do is you want to duplicate this file for yourself. Then you're going to want to upload an audio file. The way to upload audio files is to come over here. So you open this guy, this might be closed, open this arrow, and then open this arrow, and then go to upload file. And then you can just click here and you can find your file. It works fine with waves, MP4s, whatever you want to, or MP3s, whatever you want to do. I've already uploaded the audio file we want here. And actually the one thing I forgot to do, let me stop sharing and then reshare so you can actually hear the audio. So give me 1 second. But you'll basically upload that file, and then you'll have your audio file here in the sketch files, and then you'll just want to actually reference it here for this audio. So I have this thing called ionianmode.wave, and I'm just referencing the file name here. Let me stop sharing. Share screen, share computer sound. Let me make sure my audio is working. So tell me if you guys can hear this. Perfect. Okay, this is taking me like months to figure out how to do this through Zoom correctly. Okay, cool. So that's the audio file that I've uploaded here. So first things first, you want to upload your audio file. And then next, this is set up to do an interpolation. So what it's going to do is it's going to take two vector inputs. So at vector, what we call the start vector, that is going to be if you are at no sound, so if it's silent, you're going to see that image. If you are at maximum sound, which we'll call 1.0, you will see the second vector. So what we're going to do is we're going to come in here and we're going to start up our model again. This used to like actually never turn off. It would just run for days if you let it. Like I burned through so much money when Runway first started that now I'm almost like, I wish they still had that, because then I wouldn't have to wait and restart all this thing all the time. But I guess it saves most people lots of money. So I'm glad that it still works this way. All right, so now we've got our model up and running here. So let's pick out some vectors. So let's go over here, click on vector. Let's refresh this. Let me make sure. So we'll leave truncation at 0.5. Just let's make sure we remember to edit it as well in the file. So let's just come over here and let's grab, just to make it really clear, let's grab a pink one. So we'll download this pink vector. Let's just call it, oops, not that one. I want the save vector. So we'll call this pink. And let's come over here and let's grab this black one. So it's a little bit smaller and then it's black. So we'll save out this vector. Let's call it black. Okay, so now we've got both those vectors. And once again, what we want to do is we want to put them in my desktop. So we're going to open both of these inside of a code editor. And we're going to copy the pink vector, and we're going to come back over to P5, and we're going to, this time, unlike the other version, which was like an array inside of an array, we only have one vector for each of these. So we're actually just going to delete the vector that already exists there. So it should just be equals, and then we're going to paste in that vector. And then we're going to come back over here, and we're going to grab the black vector, and we're going to put in end. And I said the truncation value was 0.5. Okay, so settings for this one are, you've got a truncation value, you've got where your audio file is. You can stream an audio file, so if you have a web URL for like an MP3, you can place an MP3 in here. P5 has a weird limitation, I believe, where any files you upload have to be smaller than 5 megabytes. So if you have a really long sequence, you might want to so first off, I would say start with a short audio sequence. Otherwise, you're going to be generating thousands upon thousands of images. If you upload like a 4-minute song, you're going to be downloading files for like the entire night. So start with something short just to get a feel for it. And then you maybe figure out if you want to go for longer from there. We're going to do download images true. Frames per second. There's unfortunately some weirdness going on in that the way that P5 reads audio does not sync up to the way images get exported. So we'll have to deal with a little bit of this. I'll show you the easy way is again to dump it into After Effects and like make them match. I'll show you the hard way in Ffmpeg. But yeah, we'll just see that this is gonna be a little confusing. So this doesn't really end up being the accurate frame rate, but just put in a frame rate. And then we've got a height and width. So all we have here are 2 vectors. So we're going to go at 0 vector, you're going to see the start. At n vector, you're going to see the end. And then for any sound that is less than 0 or 1, you're going to see some interpolation between there. So this audio file, I think, is like 10 seconds at most. So what I'm going to do is I'm just going to go ahead. The way this works is you press play. It's going to play the audio file. So actually, it'll be down here. So it is going to play the audio file. It's going to basically record the values of the audio file. The problem with with P5 audio is it doesn't map it always to 0 to 1. So what we have to do is we actually have to record all the audio sequences first, and then we have to figure out what the smallest value is and the loudest value is. And then we have to do a mapping of that from 0 to 1. So basically we're going to like figure out what the min and max volume is, and then we create a mapped value for each frame, and then we pass that into our vector. So again, we're using this lerp value where we're saying start vector, end vector, and then we've got a mapped value between 0 and 1 to say how far along that interpolation we want should be. This is using this crazy library called num.js, which I don't know if anyone's a Python person in here, but NumPy is like a must-have Python library, and there's really no version of it in JavaScript. So I like found this like janky half-assed version of NumPy, and it works in JavaScript. So if it breaks, I'm sorry, but like, yeah, it's kind of makes it easier for us. Again, if you don't care about the code, don't worry about it. This should work as is, fingers crossed. I tested it out last night, but basically this is the process to get this set up. So a lot of setup just to generate a sound sequence. Maybe Chris or other folks at Runway will see this video and be like, we're gonna steal that idea and build it in Runway. And then the next time I teach this class, I get basically see. Okay, so we're ready to get going here. So we're gonna go ahead and press play. I wanna make sure my Runway model is, my Runway model stopped. So make sure it starts again. This is something that always happens is I hit play and it gives me an error message. And more often than not, the error messages are usually that your Runway model is stopped and it can't communicate with it anymore. Of course, now this one's gonna be slow. It's because I didn't press on the button. Now it's fast, of course. Okay, so now we're running over here. So we're gonna go ahead to P5 and we're gonna press play. And you will hear the audio sequence run once, and then it's going to stop, and then it's gonna calculate our images from there. I hope. Oh, hold on. That didn't play the audio. That's weird. Well, I think there's some audio sequence issues here with Zoom. So let me just play it, and I believe it will generate our images. Okay, I know it's working because it's animating. I think there's just some sound in and out issues, which is what I was dealing with on Zoom before. So this is going to generate 159 images. Again, we can't really see it So like some of this is also like this process isn't perfectly set up in that you can't hear it and see it at the same time. But I can tell from testing this with this audio piece that it is working the right way. So what we're going to do is, again, the hard process of this is we're going to generate a video of our still sequences, so it'll be silent. Then we're going to use Ffmpeg to actually recombine them. And recombining them will cause us to actually have to like change the length of the video a little bit to match the audio length. But it will look good in the end, I promise. It's just a little bit of a headache to get there. But I have to say this actually like fairly approximates how I do audio reactive work. Because there's no real time in StyleGAN, you do have to do this sort of like 2 or 3 step process to make these videos.
There's probably some way that you could kind of like fake it, where you like download a set of images that then you like navigate on an X or Y like trajectory based on some kind of parameter, could be from audio or whatever. But it's like you're never going to go outside of a range that you set, but you have all those images downloaded.
Yeah, you can almost create like a what's called a T-SNE grid, which is like a grid of images, almost like what you see in the runway vector input. And you could say like, you know, base is like X, Y, and then like, you know, continuous time is this. There's a lot of different techniques you can use with this. And I think it's like, this is showing you pretty much the most basic version, but you could also think about like, if you've done any vector math before, you can add a vector to another set of interpolating vectors, or like, you know, that sort of thing. So there's lots of different techniques you can do with this. And it just requires how much math you want to learn and how much like fiddling you want to do with this code inside of a web editor. I would say if you want to fiddle with this too much, you probably want to download it and bring it into a real code editor. Okay, so our images have downloaded. So we're going to go ahead and just put these all into a sequence. Grab all these. Audio. So the first thing we're going to do is we are going to convert these still sequences into an image or into a video. So we'll do CD into that folder, and then we'll press up again. And I'm going to put the frame rate back up a little bit higher to like 24. This doesn't really matter because we're going to stretch it to fit the audio length in the next step. But just in case, we'll do this work just to make it sort of play nicely. So we'll do Ffmpeg, actually we'll just call this video. So we've got a video sequence here. So if I go ahead into my audio folder and I hit play on this video, you can kind of, if you remember what it sounds like, you can kind of see it already working. Cool. So next thing we need to do is we actually need to add that audio to the video, or we actually need to combine them. So I've already saved that WAV file. I don't think Ffmpeg plays nicely with WAV files. I converted it to an M4A file. So I'm actually just going to put that inside of this file, inside this folder. Right. Cool. So now if I open this inside of QuickTime, it's going to open inside of iTunes, of course. I played with this all last night and I got so sick of this sound. Okay, so you'll see this is about 5 seconds. If I open the video, it says this is 7 seconds. So these two things don't line up. The simplest way to do this is just to drop them in After Effects and stretch the video to match the length of the audio. I'm going to show you the overwrought and very complicated way to do this inside of Ffmpeg because I looked it up last night and I was very proud of myself to actually figure it out. And also, like, I don't expect everyone to have After Effects or Final Cut or Premiere in here. So this is a way to do it if you want to do it. So we've already moved into that folder name. We've already run and generated our video. So now we need to run this command, which is ff. I don't even know what this thing does. Basically, it gives us the length of the audio file. So I'm going to paste this in here. And that is going to give me an error message when we press up. So I want, really want to not wrap. There we go. So I'm just going to replace this audio file name with the file name of the audio file. So it's audio.m4a. So that gives me the length of the audio file, which is like 5.3 something seconds. And then I'm going to do the same. I'm going to press up, and instead I'm going to look at the video.mp4. And the length of that one is 6.67 seconds. So now I need to run this next command, which is this. And this is going to, so the way this works is you take the, you basically just use this exact command, except for this pink value, you replace with the number you got from 5. And this value you replace with the number you got from 6. Basically, all this is doing is it's saying, take the length of the audio divided by the length of the video and give me that percentage and generate a video of that length, or like compress the video to that length. This is all very complicated stuff to just say, like, if you follow this command exactly, it should work. So we're going to go ahead and test this here. So I'm going to paste this in, and I'm going to call my file, I'm going to call it combined. So I want for this first value here, this is going to be this one, so it's going to be 5 point whatever. And for this value here, I'm going to make it this value here. You can see this is like very complicated, and I recommend if you have After Effects, you just use this. You just use After Effects or some video editing software. But if you want to do the Cody way, this is how you do it. So we're going to go ahead and run this, and it's basically going to combine our audio and our video together. And if I open up Combined, so it did actually work. It might be off ever so slightly because of frame moving around, but it's already sort of like a little bit of a wishy-washy process. So is the entire process to get an audio file working. And you'll see that because of this music, because it's like, you know, silent, key press, silent, key press, it does just sort of bounce between the same values. And this is where you may, like, if you dig into the code a little bit more, you may want to do something where you like are taking an interpolation and you're moving, you know, seamlessly along a line, and then you use that value to bounce it up and down from those points. So you would almost have like a start end and then like a bounce value or something, or a bounce vector, where you're moving it to that vector as you like move through things. So there's lots of different ways you can play with these things. And like the truth is, like, I could probably teach an entire class just around like generating different ways of interpolating this. But I just wanted to give everyone a sense of like using P5 or using some external library as a way to manipulate these vectors. You can do much more with them, and you can make them audio reactive. You can do, you know, text-based things. You could eventually do even like mouse, or maybe even record like a hand gesture video and record points of your hand and have that manipulate the value here. So P5 is the simplest way to do that, but I do know that there are people working on stuff for like Touch Designer or other tools where you could begin to program those values using these other pieces. So this is pretty early days. Like, you know, Runway's always supported this, but it's only really like become recent that people have really like started building tools for these. So there's lots of opportunities to see this grow. And I think we will over the next year see a lot more different tools working with StyleGAN or Runway in a way that allows you to manipulate stuff. Okay, that was a whole lot of demo for me. Any questions?
I have a non-audio or P5 related question that kind of connected to the first half of today's lesson, and that's just as far as exporting stills, going into the physical printing world. Do you have any upres software recommendations? I've never really tried to like upres something and print it out, but I was curious to know if you have experience, or like what your recommendations might be software-wise.
Yeah. So there are some super res models inside of Runway. If you go back to models and you go to my models, or sorry, models, and then you go to category and you go to workflow. Is this right? No, not workflow, post-processing. So post-processing, there are two models. There's one called image super resolution, and there is another called SFRBN. These are two models that do super resolution. I will say they're a little old now. They're maybe not the best versions out there, but they do it out of the box. So you could just like upload an image to it and have it export. The tool that I generally recommend folks try out is a thing called Gigapixel AI. This is a tool from a company called Topaz Labs. And this is basically like they've trained their own models to do like really high resolution, like high quality photo. The downside of this is it is $100. So it's $100. And I think you get grades for like the next year or two. I have a discount, or I have a referral code if people do want to buy it. I think gets you $15 off. They do a 30-day free trial, so you could always start there. So I definitely recommend downloading it for free, trying the 30-day free version, seeing if you like it, and if you do, like, let me know and I can give you a referral code for like a couple bucks off. I do find this generally produces better looking models just because it's been trained on like such really good photographic details. So especially if you're working with stuff like photographic models, this will generally work better. But those other models that are in Runway will also work fairly well. The truth is, all these models, I personally find that they're like slightly better than Photoshop, but like not that much better than Photoshop. And actually, that reminds me, Photoshop actually now has an up-res model in it as well.
Do they really? Crazy.
Yeah, it does. So it just added it. Let me open this and I can show you how to add it, because there's a trick you have to do to get it, to make it available for you. And they don't tell you that that's what it is, but that's what it is. So let's just go ahead and open up one of these images here. So if you go to Photoshop and then you go to Preferences, and I believe Technology Previews at the end here, and you just check this box that says Enable Preserve Details 2.0 Upscale. This is a machine learning model. I don't know what it is, if they trained it themselves or if they're using an existing model, but this is a machine learning model. So you just check this box. As soon as you check it, it'll be available in your image resizing. So then you can go, what is it, Shift Command I, image size, Option Command I, and then if you make it bigger, so let's make it ×2. And then you click here and you'll see Preserve Details 2.0. So again, there are like probably hundreds of different super resolution models. All of them work slightly differently. And this one's free if you're already on Photoshop. The Runway one is 5 cents if you just want to play with it. There are many, many others on the internet that you could also play with. And I generally find that they all work okay-ish. And none of them are perfect and none of them are the best. So especially if you have like really small images like 256, using upres will be good. For an image that's already 1024 by 1024, upresing it will just get you like you said, printer, like you'll be able to print it. But I wouldn't expect it to like blow you away in terms of quality.
Gotcha. Okay, cool. Thanks for that Photoshop tip. I had no idea.
Yep. Yeah, Photoshop is adding a couple other like machine learning models into their tools. Like if you've ever done the select and then the subject area, this is a machine learning model as well. So they don't really tell you that a lot of their models are using machine learning, but they're starting to use more and more machine learning inside of their tools. So you actually see like this, that was pretty good. Selected kind of exactly what I would say is the subject, including what I would not want to be the subject. So yeah, they're adding a lot of tools in there, and it's sort of like they're sneakily being added in, but they're doing a lot more with this stuff as well. And I expect to see a ton more out of them in the future as well, especially in Photoshop. There's a really great, if you happen to have like, I happen to have LinkedIn Learning through my job. There is a series on LinkedIn Learning, which was lynda.com for a while, right? There's a series in there called Machine Learning for Photographers, and it goes through like a ton of different tools that photographers can use to create really like new sort of photographic sequences with machine learning models. Topaz Labs, the folks that make Gigapixel AI, have a ton of other tools that are also all machine learning photography tools. So a lot of people like use them. There's a couple other big players, including like Adobe, who are starting to do more of this work, because especially for photographs, you can do a lot of like little sequencing things that can really change your workflow and do a lot of other work. So you know, that's probably the first place that I think you'll see a lot of new machine learning stuff come out of and be production ready. Whereas a lot of the tools that we're using in Runway are like cool and weird, but like you don't really necessarily see like, I could use this tomorrow on my like design work or whatever. So yeah, I think, again, early days for a lot of stuff. And I'll talk about this more next week as well. I'll do a little bit more on like where else you can start to pick up other things and that sort of thing. So yeah, there'll be a lot more stuff coming down the pipe, I assume, especially from Adobe.
Cool, thanks.
Yeah. Cool. So we're going to end a little early today, and I just want to remind folks that I'm going to share my screen again. So next week we're going to present. So just present some of your work. Again, this is loose. I've like sort of set up this sign up sheet for 10-minute increments. So basically from like 7:30 to 9, we'll just like share some work. So I've got about 30 minutes of lecture that I want to do next week, just about sort of like next steps or other things you might want to check out as videos or books or that sort of thing to keep learning. And then we'll just do presentations. So again, the presentation can be like, if you have 2 minutes of things you want to show, that's fine. We'll talk about your work, or like maybe we'll just like chit chat about like what you're interested in, that sort of thing. And we can talk a little bit more about, maybe where you can find some other data sets or, other ways to like, keep working on this stuff. Hopefully I can also like give you like, it won't be feedback and maybe like this sucks, but it'll be me just being like, that's cool. Like you should also go look at this thing and maybe learn more. So I don't expect any of us to be like, this is good or this is bad. Like we've all spent like 4 weeks on this stuff. So I don't expect like anyone to have groundbreaking things, but I am excited to just sort of see what everyone makes. So again, there's no pressure here. Like if you were able to do stuff in week 1, but you weren't able to make anything else since then, just show us what you made in week 1. Like that's really it. There's no pressure here to like make perfectly presentation work. Like it's just a free time for us to chat and like have everyone sort of give you feedback, or maybe say like, oh, this would be cool if you like use this model, or like I played with this model and I think there'd be some interesting things to do with this. So yeah, it'll just be a fun time for us to sort of see everyone's work and maybe ways for us to like chat about next steps and like keep working on things. So sign up if you want. If you have a particular time you want to sign up for, if you you have to leave at a certain hour next week, like sign up for it. Basically tomorrow or like next week at like 6:30, if anyone's name isn't in there, I'll just add their name to a time slot. So, again, there's no like pressure to be the first or second or last or whatever. But I just will have there for me so that I know we make sure we cover everybody's work and to keep me on a bit of a time schedule for everything, because I will talk forever if you let me. So yeah, so that's it. Other than that, like these slides are already up, so you can already grab the P5 example code. Video from this demo will probably be up in the next hour or two. So I'll upload that and I'll let everyone know when it's ready to go. From there, please feel free like to DM me. If you have any questions about anything, if you're like trying to make something and you can't get it to work, I'm happy to set up time to like talk over the next week, whether it's like over Zoom for like 10 or 15 minutes, if anyone is like really excited to like try and make something and they can't figure it out. And if not, I'll see everybody next week, and hopefully we see some cool stuff and we can just talk a little bit more. Sound good? Cool.
Awesome.
All right, so I'll drop the link to the sign up sheet in our Slack channel as well. But yeah, otherwise just I'll see everyone next week.
Thanks, Derek.
All right,
See you
thanks
later.
everybody.
Have a good night.
Thank you.
Thank
Bye everybody.